one, just to make sure we have this down. And I'm not going to make fun of anybody here right now, but if I give you something such as this, okay? If I gave you f of x equals x minus 3 squared plus 5, okay? And this is for you to know, okay? And what I mean is, you should be able to describe this graph and graph it pretty quickly right now after spending 3 days on this. So you really should have this down right here. And in case you've forgotten it, these are things that you're going to need to remember. How you're going to do this, first off, you should know it's going to be a parabola. It's going to be quadratic because of the square. Okay, it's going to be U-shaped, okay? Actually, I'll tell you what, I'm going to make it like this. Put a -4 right there also. It's still going to be U-shaped, okay? But you should know that this plus 5 off by itself moves it up 5. This minus 3 with the x, think of this. This is huge for what we're going to be talking about today. Everything with the x is always the opposite. It's always the opposite, okay? It's always the opposite, okay? So an x is horizontal, okay? Keep that in mind. So everything with the x is horizontal, and it's always the opposite. So this right here actually moves it right 3. The minus sign flips this thing upside down and reflects it over the x-axis. I'm going to write flip. And that 4 is going to stretch it vertically because it's bigger than 1. Okay, it was brought up the other day. Well, -4 is smaller than 1. Well, the negative we've already dealt with. Okay, the negative flips it. This is going to stretch it. So if I was to graph this thing, I would go 3 spots to the right, and up 5, and put a dot, and have a parabola opening down because it's flipped upside down. It's going to be, if it's stretched, it's going to be a little skinny. Okay. Any question on that? Okay. Now that's old stuff. Nothing new there. That's old stuff. Now the new stuff, okay, if I was to give you something such as this, I apologize, I lied to you guys, I didn't realize it comes so quickly. Remember how the other day I said horizontally, yeah, nothing's horizontal, we're going to deal with that later, like in a few weeks or something like that? It's today, actually, I didn't realize it was the very next section. So, and it'll be okay, we'll take it real slow right here, okay, as long as you can remember one of the things I just told you guys about with everything with x is always the opposite, okay? So if I give you something such as this, f of x equals, let's try absolute value of 2x minus 5. Okay, absolute value of 2x minus 5. Now, at first, you should know that this absolute value is V-shaped. This is going to move it down 5. Now, something else I'm going to say very slowly. And I've said this before, I just want to make sure you guys have caught this, and I think you guys know it. Whenever you add or subtract, it slides it around. This plus 5 slid it up 5. This minus 3 slid it 3 to the right. Adding and subtracting slides the graph around. When you multiply, it stretches it or shrinks it. When you multiply, it stretches or shrinks. So this 2 right here, that does not slide it at all. It doesn't slide this thing at all, okay? It's either going to stretch it or shrink it. Well, let's backtrack a couple minutes. I said that x, if it's with the x, it's left and right. It's left and right, okay? So in this case, since we're multiplying by 2, it's going to stretch it horizontally or shrink it horizontally. Now, what would you think? Would you think it would stretch it horizontally or shrink it if you times by 2? What would you think? You think it would stretch it or shrink it? Stretch it. Why? 2's bigger than 1. You'd think it would stretch it. Everything's the opposite. It's going to actually shrink it. It's going to shrink this thing. And again, it works 2 ways. Just like when it's vertically, if you stretch it vertically, it gets skinnier. If you shrink it, it gets fatter. Well, you would think it would stretch it horizontally. It actually shrinks it horizontally. And if you push something in, what's going to happen? It's going to stretch up that way, okay? What if it stretches horizontally? It's going to also shrink vertically. It can't do one without the other, okay? It has to do both, okay? So this one, since we're timesing by 2, it's actually going to shrink it horizontally. Okay? So again, everything with the x is horizontally. This is not with the x. It's off by itself. That minus 5 is off by itself. Okay? And it's always the opposite. You think it would stretch it horizontally, it actually shrinks it horizontally. So a quick, rough graph would look like this. If my original graph looks like this, if my parent function looks like that, this thing is going to move down 5, okay? And you're going to shrink it horizontally. So, stretch goes this way, so shrink's going to go like this. So what else is going to make it look like? It's going to, if you push it in this way, it's going to almost, so this is where it's a little bit tricky. did it shrink horizontally or did it stretch vertically? Well, I mean, it kind of does. It can't do one without the other. It really can't, okay? I mean, it said that it's going to shrink it horizontally, but both things happen. Again, think about silly putty, okay? If you're going to shrink, if you have the silly putty, you're going to shrink it this way, you're going to push it this way, you put it in the machine, it's going to put a big old wad of silly putty. It's also going to start going upwards. I mean, it has to squirt upwards and downwards, okay? So it can't do one without the other. Let's try another one. And then there's something else we still need to talk about. We may not even start the assignment today. We just want to talk about material that may just started on Monday or Tuesday. What if I gave you this? Let's kind of put everything together here. Let's do 5x, not x, let's make it 1/6 x plus 3 squared plus 7. Okay? Let's try this one, and then we got one more thing to talk about. And again, it's nothing new other than the horizontal stuff. And just remember, everything's back and forth opposite. Okay? So the plus 7, first off, this is a parabola, a square. Okay, it's a parabola. The plus 7 moves it up 7. This 5, it's not going to flip it this time. It's not negative. It's going to stretch it. Okay, it's going to stretch it vertically. This 5 is bigger than 1. This plus 3, it's with the x. It's a plus 3. That's going to move it 3 left. You would think it'd move it right. Actually moves it 3 left. Okay? Now this 1/6, I tell you what, you're going to hate me for this. I don't want to do both at the same time. I'm going to cross this 5 out. I'm going to cross this out. Just ignore that right there. Okay? Just cross it out. I don't want to have it do both things. That'll make it even more confusing right now. Okay? Now this 1/6, you're times it by 1/6. If you times by a 6, what would you think? Would you think it would shrink it or you think it would stretch it if you times by a 6? You think, why?
Because it's smaller one.
Yeah, you'd think it would shrink it horizontally. You think it would shrink it like this, but it's actually going to stretch it. It's going to stretch it horizontally. Okay?
So how can you tell the difference between, like, if you have the horizontal or
Well, it depends.
What's
on
that?
the question.
like how do you figure out the difference between if it's vertical or horizontal? Because like in section 1.1, the problem is just like this and it's vertical.
Well, what they're going to do is they're going to give you a function. They're going to say stretch it or shrink it, vertically or horizontally. So if I gave you something like this, y equals absolute value of x. Let's do just a basic one, absolute value of x. If they say shrink it vertically by a factor of a half, shrink it vertically, that's old stuff, okay? You put the half out front here, okay? Now, what if they say they want you to do it, they want to either stretch it or shrink it horizontally? Then you would put it inside there. They'll tell you whether they want it horizontal or vertical, okay? So if they said stretch it vertically, stretch it horizontally by a factor of a half, it'd be in there.
So horizontally it's with it, vertically it's outside.
Perfect. Yep. Horizontally's always got to be with the x. Always got to be with it, okay? Vertically is going to be off by itself. Okay, good question. Okay, now you might want to make a note of that. Okay, now the last thing, I would and I'll tell you what, on your first test, whenever that is in a couple, 3 weeks or so, I'm 99% certain I will put this on the board for you, okay? Or I'll put it on your test. You won't need to memorize this, okay? Because this is really tough to remember. We're also going to we've reflected over the x-axis. We've done that, okay? Remember we put a negative out front and flips it upside down, okay? We're also going to reflect it over the y-axis, all right? And I think somebody, I don't know if it was this class or the other class, somebody asked, well, how do you do that? And I said, don't worry about it yet. Well, worry about it today. Jot this down for reflections. Okay? This is what I'll very likely give you on your first test. Not just give you a problem, I'll say, here's what you do. You just have to do it. Okay? Okay. Over the x-axis, here's what you do. It's over the x-axis. Change everything opposite. Change everything. Change everything. Okay? So, what I mean is this. If I gave you y equals, say, x plus 4 squared minus 3. Okay? And I'm going to take this real slow. This is where it gets a little bit tricky. Change everything to the opposite. So here's what you do. You put a negative right here. You put a negative out front. Now, time out on this one. Put this on hold. If I give you this right here, 3, 2x plus 7. Without giving any instructions, what do you think I'm asking you to do right here? Without any instructions whatsoever. If I just give you a problem like that and I say, go ahead. You could graph it, something else. I'm glad you said solve for x. Be careful on that. I'm not making fun here. You can't solve for x. Nobody here, myself included, can solve for x. You can't. And it's kind of like this, and I've never talked to you about this. If I give you this problem right here, 1 plus 2, nobody here can solve that, myself included. If you're going, yeah, I can, it's 3. You didn't solve it. You simplified it, but that's impossible to solve. It's impossible to. Anybody know why?
Because you can't get an x equal.
Well, even something like this, 3x plus 2x. Nobody can solve that. You might say, yeah, it's 5x. You've simplified it, but you didn't solve it. Now, if I gave you this, now it's solvable. Why? In order to solve something, you got to have what? What's that? What's this thing got that these things don't have?
It has an answer to it, it's called.
Yeah, but what's before the answer? It's got an equal sign. You got to have an equal sign. You got to have an equal sign, okay? So, good try on this one. You can't solve for x. What do we typically do if you got a number sitting next to parentheses? Yes, sir. Distribute it. Now, what gets times by 3? The 2x or the 7? Okay, what if there's 5 things in there? All of them. Everything in there gets that 3, okay? So, if I put a negative out here, is that thing negativized?
Yeah.
Sure. Is this negativized? Yep. Is this thing negativized? No, it's not in the parentheses, okay? So, I said change everything. We've changed this. But we also have to change that. Okay, so if I did that, it would be negative x plus 4 squared plus 3. If I graph this, and then I graph that, it'd be the same graph, but I'd be flipping it over the x-axis. Let's try one more like that. And then we got to talk about the y-axis. Okay? So if I gave you y equals 4, absolute value of x minus 9 minus 7. Okay? Now absolute values are not exactly like parentheses, but they kind of behave similarly, but they're not exact. So if I said reflect that over the x-axis, you would have 4 would turn to negative 4. Am I going to change the signs on these things? The x and the negative 9 or not? Yes, ma'am.
Can I move to one of those?
Yeah, that's fine. Okay.
So the top example was also reflecting over the x, right?
What we're saying is here's a function, okay? I'm telling you, reflect that over the x-axis, that's what you get. Here's a new function. I'm saying reflect that over the x-axis. So I made that negative 4. Am I going to oppositize these things also or not? Did we oppositize these things? No, that negative took care of it. So we're still going to have x plus 9. Are we going to oppositize the minus 7? Yep. It's not in the absolute values. So again, what I'm getting at is this. If I graph this, and it would look like a V, this would look exactly like that same V, but flipped over the x-axis. Okay, reflecting over the x-axis. So, when you reflect over the x-axis, change everything to the opposite, okay? Now, what if I reflect over the y-axis? On the y-axis, what do you do? Change only the x terms to the opposite. Okay? Only change the terms that have an x to the opposite, okay? So we're going to reflect over the y-axis, change just the terms that have an x in it. Just those, that's it. So an example, let's do a line. Y equals 3x minus 7. Now, if I was gonna reflect it over the x-axis, I would change that to negative 3x and change that to plus 7. But since I'm changing just the x terms to the opposite, I'm only gonna change this one. So it's gonna be negative 3x. Am I gonna change to minus 7? No, why? Ain't got an x. Minus 7. So, if I graph this, and then I graph that, it would look the same, except it's reflected over the y-axis. Instead of reflecting it over this x-axis, up and down, it's going to reflect it left and right. Let's try one more. How about y equals x minus 8 squared plus 3. And again, if I reflected over the x-axis, I would have made this a negative here and make that a negative here. Okay? So, change just the terms that have an x. So this first term, x, what's that going to become? Negative what? We'll make it harder than this. What's the opposite of x? Negative x. Am I going to change this minus 8? No, why? No x. So minus 8 squared plus, am I going to change to 3? No, why? No x. Does that make sense? When you're over the x-axis, change everything. When it's over the y-axis, change just the terms that have an x on it.
So why didn't you change the terms inside the parentheses on the top one, but you did inside the...
Which ones? You talking about these ones?
Yeah, so you didn't change the term x plus 4, but on the other one, you changed x minus 9 to x plus 9. What changed?
Ooh. I made a mistake is what happened. Shoot. Did that confuse a lot of you guys? Speak up earlier. I'm going to yell at you guys. Speak up earlier. I screwed up. This stuff's confusing enough, let alone when the teacher screws up on it. Okay. Sorry. Good question. That should have been a minus.
I was mainly just listening, so I don't know.
Did I say, did anybody know, did I say minus and wrote plus, or did I put?
You said minus, I put minus down.
Yeah, me too.
I think I probably said minus and wrote it wrong, so, but still, that's confusing. This stuff's confusing enough. I apologize, I screwed up. And please speak up earlier if you see something. I'll make mistakes, and I'll tell you what, I make mistakes on purpose quite often, just to see if you guys catch them. I just screwed that one up. So, perfect, yeah, that should not, I should only change that. Yeah, same thing here. I didn't change the plus 4. I shouldn't have changed the minus 9. I did on accident, so, all right, good catch. Okay, any other questions? Yes, ma'am.
This is like way back. Okay, on that one,
Which one?
the other one.
Over here?
Yeah.
Okay.
Why did you cross out the 5?
I didn't want to, rather than, we're just introduced horizontal stretches and shrinks, I didn't want to put both in the same time. I just altered the problem. So yeah, there's nothing, I didn't want to confuse you. Which confused you, so it's kind of ironic. So, any other questions? Okay, so here's the deal, okay? If you're done with section 1-1, if you want to at least look at section 1-2, that's up to you. You guys get a little head start. I'm not going to require you to do any of section 1-2 right now. You guys got about not quite 24, 25 minutes or so. I know a lot of you still need help with, or need time to work on section 1-1, so use this time to work on 1-1. If you have questions, ask. People at home, if you want to work on section 1-2, you can start that. We're going to continue on. When we come here on Tuesday, we're going to start with 1-2. We're just going to dive into section 1-2.